Hello and welcome back to the Fullerton College Prepress class. This is your instructor, Ben Hewitt. Today we're taking a look a second time at trapping. When we last left, we just talked about how trapping is slightly overlapping different adjoining colors on a multicolor print job to ensure there's no gap in case the plates misregister or things change during a print run. We talked about different terms of things like choking and spreading. Choking is when you take the background and shrink the white space in the middle of it so that the thing printed on top overlaps. And the opposite of that is a spread, where you take the on top printed color and you make it bigger. Either way, and we'll get into this more as we talk, the darker color is what ends up defining the outline of a print job. And then we talked about stroke. Stroke is an outline, but outline strokes are typically set to overprint, so you can actually use them to manually set up traps for manual output. Okay, no more words here. We're still going through the language of trapping. A net fit is a multicolor work where the colors do not trap and there's no tolerance for misregister. That means you're going butt to butt, as you might call it. That means that you are gambling on nothing happening during your print job that would cause a misregistration. You are saying that we are going to run this so tightly controlled that we expect no problems at all on press. I would love to live in that world. Okay, hairline register and tight register also means, it can mean the same thing, or it can mean something that has a very, very tiny trap. It also means you're gambling on very, very, very good control over the print process that's going to have very little to no variance during the print job. Now, if it's a short enough print run, you may have a better chance at this working. Loose register or no register, you can actually have a print job where you do not need to do any trapping at all. If you have a mostly white sheet of paper with some black text and somewhere else some other colored text or some colored backgrounds that nothing is printed on top of, just like, a colored square or shapes or something, you do not need to trap. If there's no colors that touch each other, then there's no reason to trap it. That trap is only overlapping when they would otherwise meet. Now, a lap register is also a way of saying the job has been trapped. There's two types of traps. There's solid traps and there's blended traps. Solid traps means you use the full value of both the colors that touch. A blended trap means you dial them both back, and we'll look at those in a bit more detail right about now. Here's a great picture exemplifying the idea of the solid trap. So you print this green and this purple, or I guess more of a maroon, this green and this maroon on top of each other, and you overlap them enough that you get a solid color in the middle. You can actually start to see the trap much more clearly because it's going to be a much darker part of the page because you have more, like double the ink in that space, or more than double. So a solid trap is a more of a blunt force way of doing these things. It gets the job done, but sometimes the trap becomes noticeable. So instead of seeing that little gap of white paper between colors, you see a dark line outlining where the colors meet each other. It can't be preferable, and sometimes people don't appreciate it anyways. A blended trap, however, you take the edge of the object and you dial it back in intensity. So you print a half-tone version instead of a solid version of each of those. The idea here being they overlap where they touch, but also the combined area of the trap where the two colors meet is no darker, or I guess I should say, has no higher percentage page coverage than it would have already been at one color. That way, it does not show up as a darker thing. Remember that the human vision system, it's much more sensitive to light to dark shifts than it is to chromatic shifts. We are designed to see light objects on dark backgrounds and the other way around. If something is significantly lighter or darker than something it's next to, it will be noticed. This makes sure that the overall tonal quality from light to dark stays uniform across the whole image and you don't notice the trap as much. Let's flip between these real quick again. So that's solid and blended. Solid, blended. You see how you don't even really notice the blended ones so much because the darkness is not increased significantly. It's a clever work. I like it. Okay, so the rule for how to do a good trap is you always modify the weaker color. The stronger color is what defines the outline of whatever objects or text you're working with. The weaker color is always the one that gets modified, the stronger one you leave alone. In the top TR up there, I'm sure it's TR for trap, you'll notice that it looks about right. It's a little bit dark around the edges where the yellow and the blue overlap, but it looks about correct. That's because they spread the yellow. They made the yellow wider to cover the gap. The blue defines the edge of the shape, and you spread out the yellow over the top until it's fully filled and overlapped a little. If you go the other way, look at the bottom one here, you see that they choked the blue. They made the blue bigger to overlap, but what that did was make the whole word look like a bad photocopy of itself, and you lose the edge and you lose the shape of the text. Modify the weak color, let the stronger color hold the shape. How do you determine the weaker color? Well, it has to do with the types of inks being used, and there are many variables in this as always. But typically speaking, well, depends on the white, doesn't it? White is the weakest density because if you're talking about white in the terms of like how Adobe InDesign defines it as the color of the paper, that will be the weakest. You can't do anything with it. It's so weak that it is just not being printed. It is very different to talk about an opaque white ink. That in fact is up there with metallics, but that's not a part of this curriculum. Just letting you know that if you're using a press with an opaque white ink, a lot of UV inkjets do this, that opaque white will actually be extremely strong and it will cover whatever's under it because that's what it's designed to do. But in this case, white just means no printing. Then you have yellow at the bottom, followed by cyan, followed by green, magenta, red, blue. Black is the most dense, except unless you're using metallics. Metallic inks typically have little filings of actual metal in them. To dumb it down and make it sound worse than it is, it's literally filled with tiny glitters. Though thankfully it's suspended in a liquid, so it's a stabilized, safe glitter that won't get on everything. So you want to do the minimum size trap necessary, otherwise you get a halo. And in this case, halo means that kind of edge where the two overlap. And if it gets too wide, it actually creates a third color that wasn't ever intended. And that looks funky. People don't like it. And clients really don't like it, especially if they did the design themselves. They're like, great, I gave you a picture with red and blue, or sorry, yellow and blue in it. Why is there a green outline on everything? And you have to explain what trapping is. And ideally, you just don't want it to be noticed. This is something you're doing partially behind the scenes that makes things look the way people think they're going to look, not change the appearance to something new. If two colors are trapped with similar density, choke the background color into the foreground object. And backgrounds should always choke into photographic images. Digital traps are capable of creating traps only in colors that need to be trapped. If you're using any sort of software to do your trap that's being done automatically or done by algorithm, and it's been programmed in the last 15 years, there's a good chance it's already going to choose when and where to use and when and where not to employ. It will know that there are some colors that aren't touching, so it won't mess with them. And if there are some that will work just fine, it'll leave them alone. There are some that will still need to be done, and it will apply them where and if necessary. Now, common colors. We're talking about process printing when we talk about this one. The common colors that don't require traps means if you're doing two colors that overlap each other and they both contain some of the same, but not all of the same process colors, it's not an issue. On the left, you need to trap that because you have the magenta for the letter A and the background green square, rectangle, is cyan, yellow, and black. There's no magenta in the background and there's none of everything in the background in it. So you must trap that. However, on the right, you don't need a trap. They both contain, both the letter and the rectangle it's in, the foreground and the background contains cyan and yellow. In which case you just add the magenta and the black to the part that you want it to, so to speak. That's all it needs to happen. So there's no trap needed there because the cyan and the yellow simply continue and other colors are added on top. Trapping gets more complicated like this in 4-color process. When you're just using solid colors or like Pantone spot colors, trapping is almost always a must. But once you get into process color, sometimes it's not required, and that's delightful. Trapping methods. You can do it semi-manually using Illustrator. You can do the same thing with QuarkXPress or InDesign and page layout software. Photoshop can do it, or Prepress workflows can do it. Things like Agfa Apogee, Kodak Printergy, Heidelberg Prinect, uh, Fiery by EFI is another one that's commonly used nowadays. The Xerox workflow, free flow work servers, all of those can do the color trapping and do the color trapping themselves. In fact, trapping is so common nowadays that it often happens without you knowing it. So some of this chapter is one of those things where you're learning about what's going on under the hood, things that you can understand for troubleshooting, but don't really have to do, but you do need to understand. In Illustrator, you can use a Pathfinder palette to make a trap. Trapping is actually a function you can do. You can also do it manually by setting up strokes when you're putting things together in here. In Quark, you go through and you can use the trap information palette, but only things that are made in Quark Express get trapped. Things you bring in from other places do not. In InDesign, if you build it there, you can trap it. If you bring it from somewhere else, you better hope it was trapped in the other place. In Photoshop, you can add a trap under Image Trap, and it will do it for bitmap graphics. In a Prepress workflow solution, this is the most efficient way to do it because it'll do your whole document instead of on an object by object basis. These other ones we just looked at, going back through them through Illustrator, Quark, InDesign, and Photoshop, that's all stuff you do when you're doing a single image. You really want to take care of how that image traps. But overall, you can let a Prepress workflow solution and the RIP handle it. And they will do a darn good job because that is their job. But you can sometimes use manual traps for things if you're using special ink. These don't always account for things like, ultra opaque whites or metallic ink that needs to be handled manually on a case by case basis. The last part of this chapter is going to be a quiz.